Okay, so there's our first problem. The present value of an ordinary annuity, which has payments of $600 per year for 10 years at 8% compounded annually. This, at first read, I think, probably sounds exactly like what we were doing in the last section, and it's probably really easy to get these two confused. Like, how do you know this stuff from what we just did? How are you going to tell on exam number 2 in a few weeks which one's which one? So let me straighten those out for you. So what we were doing back in 5.3 was future value. They're both annuity. What does an annuity mean? What does it mean when we talk about an annuity? Series of payments. So it means series of payments. That's different than compound interest, right? Compound interest is where you put money in the bank one time, and then it grows by interest over the years, right? Annuity, you don't just put money in the bank one time, you make several payments, like every month, like a house payment or something like that, right? Or storing for retirement. Every month, just keep putting money towards something. That's an annuity, series of payments. Oops, payments doesn't have an S. Series of payments. Okay, well, there's two kinds. There is what we did in 5.3. We did, well, here, let me just, that's not a good way to erase. So that's what an annuity is. And then in 5.3, we did future value. That's what that was called, future value. Meaning, like if you have payments, and they grow real big, you want to know in the future what will be the pile. That's like storing retirement savings, for example, is the best example. Or saving for college or vacation. You know, anytime you're saving up your money, that's what we just finished last time. 5.3, future value. You're trying to save the money for a big vacation or save the money for retirement, trying to build up a pile for later. You want a future pile, future value of annuity. Well, in this section today, we're going to do 5.4, which is present value of an annuity. So what does that mean? Well, that means the pile is already here. The pile starts in the present, and we start knocking the pile down until it vanishes. 0. I'll write the word 0. So that would be like a house payment or a car payment, right? The pile starts in the beginning. Now, you might not think so. What do you mean the pile? Well, you get the car, you get the house. And that means the bank paid off the house builder or the car builder, right? They didn't just hand you that car out of the nicest of their heart or the house, right? Somebody paid for that house. The bank did. Like the house I'm living in. The bank has paid the builder for that house, and now I'm paying the bank back. So the pile was at the beginning 15 years ago, right? The pile was there, handed to me. Here's a pile of money, Brett. Buy the house. So I bought the house. Thank you, bank, for that pile of money, right? That pile's at the front, and now I spend the rest of my life paying them back for that pile, right? House payments, right? That's the present value. So you get the pile now, or buy a car, or borrow money, right? Those are forms of borrowing, aren't they? So present value, you get the pile now, and you pay it back over time. It's also called amortizing a loan or a debt, right? What does the word mort mean? Death, mortal, right? We will die. We are mortals. We're not immortal, right? When the word mort is in something, it's death. So you're putting the loan to death. That's what I'm trying to do with my house loan. But it's not dying very quickly. But, right? So they're saying, how do you take this big pile of money and bring it to nothing? Right? To where you owe the bank nothing. I can't imagine what it's like to own my own home. So someday, maybe, I'll owe the bank nothing, right? You're killing the loan. That's what's called amortizing a debt. Bringing it to 0. So that's future value. No, I'm sorry. That's present value. That's present, right? Because the pile starts now. So that's what we're going to do today. Present value. The pile is in the present. What we did last time was future value, saving up for something like retirement. The pile was in the future. And with retirement, you actually do both if you think about it, right? You store up, and then you retire maybe at 65 or something, and then you start pulling off that pile, right? And you hope to die before the pile dies, right? right? It's a race to who will die first. All right. So, all right, with all that said, some dramatic references. Let's just solve these problems. So we need a new formula. You can write these on your 3x5 card. Here we go. P for present value equals R. Last time we used S. I don't know why they use S, but it was future value. Okay, 1 minus 1 plus R over N to the minus NT all over R over N. Looks very similar, huh? Got a couple little things that are different. Got a little minus sign and some stuff. Again, I'm using different form than mathexcel.com. So if you click on mathexcel.com, the question help button, they'll show a formula with the I, and they do it a little bit different. I think this will be easier for you. Mine looks worse because I'm showing every little detail. They shorten theirs, but then, it's hard to tell what some of the stuff is. All right, so there's the formula we're going to use, and so it's just like last time. Get your graphing calculator, plug them all in. Here we go. They're saying find the present value of an ordinary annuity. Payments are $600 per year for 10 years. Okay, so remember R is always the payments, right? Just like on the formula we did last time. R is always the payments. So what is it? $600 per year. And it's 10 years. Okay, what's the R? Oh, 8%. 0.08. What's the N? Compounded annually. When you compound annually, what's your N? Just once a year, huh? N is 1. To the minus 1 times T. T is 10 years. All over R. 0.08 over N. There we go. Want to try that? Now again, I suggest, the easiest way to do this kind of thing is to start on the inside, right? You know how I always suggest on the calculator. Let me bring it up a little bit even. I would start with the 1 plus 0.08 over 1 to the power negative 10. Is that on the screen? Yeah. Right? So start in there. And remember, the calculator negative sign is different than the subtraction. It gets really upset when you mix those around for some reason. You think it could handle it a little bit better than that, but it can't. So make sure you put a negative 10, that negative with the parentheses around it, instead of a subtract 10. Okay. And then I would go 1 plus the answer. See how I'm doing the top? So we just did all this. Oh, no, 1 minus, huh? My mistake. 1 minus, and use the answer key, and hit equals, and then go divided by 0.08, hit equals. So here's the 1 minus the answer to all of that, divided by the 0.08, equals, times the 600 in the front, equals. That's how I would do it on the calculator. An answer key makes things nice. I'm getting 8310. You guys getting that? And gals? Anybody? Getting 8310. That seems funny to me.
4026.
Yeah, what am I getting 8310? My answer is crazy. Yeah, my answer cannot be right. I'll show you why in a minute for something else. It's always helpful to be able to know you're wrong, especially during a test, huh? Somebody say, I must have hit something wrong. So that's it. I was just trying to show you how easy it is to hit a wrong button. It's so easy. I don't know what button I hit wrong. See, 1.08 to the negative 10 equals 1 minus answer equals divided by 108. That time I got 4,026? Weird. Weird that I got such different. They want the cent, yeah, nearest cent. 4,026.05?
Yes.
At 4.8, so it rounds to 5. Anybody else getting that now? I heard a different answer. You got that? Okay, looks like a couple people getting that. It's easy. It's really easy to hit a wrong button, isn't it? So, I would run them twice. Definitely. I really encourage you. Please save yourself that trouble, especially if I don't see any work, guys. You see how I graded the test, right? Look it over. If I see work, and all you did was like do something small wrong, I give you a lot of the credit. But if all I've got is an answer and it's wrong, I can't give any partial credit. So a lot of these are just all calculator. So you don't want to get the answer wrong. You lose a half a grade, 5 points. So don't do that. Make sure you just run them twice. Just run them twice, like I just needed to. Is it coming out now? Is that okay? You guys getting that 4,026?
Is it supposed to come out negative on your
No.
calculator?
No, it shouldn't. That's not a good thing.
I got that, but just negative.
Well, yeah, so try it one more time. If you're getting the wrong thing, just try it like I did. Just run through it one more time. Try it again. See if you can get it. We getting it okay? Should we take a second? So the rest will be the same. So about what this thing even is. Let's make sure we're clear. Hold on for a second. So what are they doing? They're doing $600 a year for 10 years. Let's forget about all the interest and all the fancy stuff. Basically, right? They're saying find the present value of an annuity, $600 per year for 10 years. So we have a pile, present value, pile present. Right? It's all about where the big pile is. Present value means big pile now, present. Future value means big pile in the future, like retirement, right? Okay, this is present value. Big pile now. I got a big pile of money now, right? Maybe you just retired. Let's just go with it. You just retired. You get this big pile of money in the bank. You're going to start pulling off that pile to live on, right? Okay? Big pile. You're going to pull how much off? $600 every year. It's not much to live on. For 10 years. So what's $600 a year for 10 years? Just forget about all the other fancy stuff. Just 600 times 10, right? I mean there's interest in, but just 600 times 10, $6,000. You're going to pull off $6,000, aren't you? $600 a year for 10 years. You're going to pull off of that pile $6,000. How are you going to pull $6,000 off a pile that's only 4,026? You with me? You see it in the confusion? How are we pulling $600 10 times, $6,000 off a pile that's only 4,000 some? Like a magic trick. We're pulling out more than was there.
Is it the interest loss?
The interest gain. That big pile we have, like when you retire, that big pile is sitting in the bank. You don't pull all of it off the first year. You just pull part of it. The rest sits there growing. You getting the idea? So that $4,026 is sitting in the bank. You pull your first $600 out, but the rest of it sits there for a year and grows. Then you pull another $600. The rest of it sits there and grows. Pull another, right? So that $4,000 is growing while you're pulling little bits off during the year until the growth and the pull off all balance out exactly at the end of 10 years. And you've really pulled off $6,000, even though you started with less than that. That's what they talk about, the present value or the future value of money, right? $4,000 today is worth $6,000 pulled off in these kind of ways. That's when we're getting kind of into that now, when they talk about the present value, the future value of money, right? Because things can grow over time. So dollars today are not the same as dollars tomorrow, based on how you can invest them and stuff. So we're going to get more into that. Does that make sense then? What we're doing with the piles? Okay, so let's go forward then. Okay, so let's try this one. Same exact formula. See how you're going to recognize it on the second exam? Present value. So you want to write on your 3x5 card, the future value formula, which we had last time, and the present value formula, which we have this time. So the present value starts with a P. That makes it easier to keep straight. Present value is R with the bracket 1 minus 1 plus R over N to the minus in T over R over N. There we go. So give that one a try. It's all the same. I'll wander around, see if I can be of some help. All right, so I'm going to plug stuff in. What's the R always in these formulas? It's the payments, huh? I don't know why they use R. But R is the payments. The payment is the 9,000. Right, we want some, they're saying, what's the size of the pile now? What's the present value of the pile now that will make payments to us of $9,496 every quarter? So we want some big retirement account, let's say. It's all built up big so that we can pull off. This is how financial investors, these are the calculations they use. When they advise somebody how to restore for retirement, they say, well, how much do you need to pull off? How much, they of course, they also figure in inflation. But how much you need to pull off, and so you need, if you want to pull off 9,496 every quarter for this many years, how big of a pile do you need? That's how they determine all this kind of stuff. So, so what kind of pile do we need to pull off 9,496 every quarter for 7 years? If you can leave the big pile sitting in the bank while you pull little bits off of it at 6%, 6.8% compounded quarterly. So, let's see. So the payments are the 9,496. 1 minus the R is 0.068. The N quarterly is 4, right? N is 4. Minus 4. How many years? 7 years. Over R. 0.068 over 4. Like that? We good? That's what we need to do. So on the calculator then, how would I start? I would start with 1 plus 0.068 over 4. Hit equals. And then go to the power, negative 28. Hit equals. And then go 1 minus answer. Hit equals. And go. And then remember what I do with these denominator things? I flip them up. And I go times 4 over 0.068. Remember how a fraction on the bottom of a fraction, it flips upside down and comes up to the top. Remember how we talked about that last time? You got a fraction on the bottom of a fraction. Just grab it and flip it upside down like a high diver. Going back at, if you were watching the Olympics with the high diving, you run your DVD backwards. They would flip out of the water like a trout or something. Right? It's kind of like what we're doing. The high diver is flipping back out of the water to the top. So that means I'm going to go times 4 divided by 0.068. And then I got to go times the 9,496 in the front and hit equals. Somebody getting an answer there? $210,000. They want to the penny, don't they? Everybody else getting that same answer? Good. A couple of you getting it. That looks verified. So you need a pile of $210,000. $210,166.61. That pile, and then you could pull off every quarter 9,496% in years, while the pile is growing at 6.8%. That'll work. There's the pile you need to make that happen. That's the pile in the present that will lead to pulling off those payments. Is that good? Question?
So when you're talking about like house payments and stuff, so that's what you owe, or that's what you're gonna end up paying?
Yeah, you can buy a house. If this is a house, you can buy a house for $210,000, and if you do, to pay that back, the pile now, the $210,000 house given to you now, and you pay it back by paying $9,496 every quarter. Now nobody makes house payments once a quarter, but that's the idea. Yeah, you would pay it back, or buy a car. Buy a very nice car, $210,000 car. I still remember we were between houses at one point. I sold my house, and it was at the top of the market like 14 years ago. It was right when the market was going crazy. I'm no market genius. I just needed to move at that time. So I just sold the house. It was at the height of the market. I'd made a lot of money in the house in the 2 years just because the market happened to rocket up. Sold the house, and I waited a year. We went and did some stuff back in Kentucky. So it was a year before I bought the house. I was sitting in the bank. I remember I would see the advertisements, for like the Lamborghinis and the stuff, the $200,000 cars. And I remember telling my wife, honey, I could buy that car. I could buy that car. The kids would have to live in it, but I could buy that car. Really, I've got that money in the bank. I could just buy it straight out. I never did, obviously. We bought another house a year later, but yeah. So anyway, yeah. So that's the initial buy. Like that's the house pay. That's the purchase price of the house to make those payments back to kill that loan. Is that making sense? You guys able to get that? Okay. All right. Let's move on to another one. Or we get that copy down to 210. 166.61. All right, let's start another one. If you couldn't get that one, all right. So let's do that. Present value R. So 1 minus 1 plus R over N to the minus in T over R over N. Okay, so this time we're finding the payment. So we want to find R with the given present value. So this, see what it says, the given present value? So the 83,678, that's the present value. So that's like they're saying, all right, you're going to buy a house that's $83,678. Right? That's the present lump sum. That's the current value of your house. $83,678. You're going to take that and what payments are needed to pay off that house? In 16 years at 5.9% compounded monthly. Yeah, so monthly payment. This is just like monthly payments for 16 years to pay back an $83,000 house. This is exactly how they figure these out. There's online formulas that do all that. This is them. So give this one a try. What's the N? Monthly? N is 12, right? Monthly. So monthly is 12. Okay, so you got to solve that for R. So what I would do, you guys know how I suggest do this, right? Calculate this whole thing on the right side, and then 83,678 divided by answer, right? So see if you can do it. I'll come around, see if I can help. So anybody else getting that 674.42? Nobody yet?
I got 674.40.
40. 2 cents difference. 40. Anybody getting that? So how do you do it on the calculator? So on the calculator, I would start right in here. Remember, I always start with the inner parentheses, right? I would go, and remember, you have to hit equals when you're done with a parenthesis. You don't even need to use, with the method I'm showing you, everybody seeing what I'm saying? With the method I'm showing you, you don't even need to use parentheses. Just hit equals when you finish a parenthesis, and that'll take care of it for you. So 1 plus 0.059 divided by 12 equals, because that's the end of the parentheses, right? To the power. Now what is 12 times? I would do the 12 times 16 on my 160, 32, 192. Is it negative 192? Right, 160 and 32, yeah.
74.4.
To the minus. 192. You got 42?
I got 42.
Okay, we've got two people getting 40. You want to try yours again? We got two people getting 42 cents. We probably need those 2 cents. Roberto, you getting it?
No, I got 400 left. Let me
Oh.
double check though. I did one giant there.
Got a cheaper house payment there. All right.
Alright. This was cheap.
And then go 1 minus answer. See how I got this whole answer? And then 1 minus answer equals. You got it. You got them 2 cents. You found those 2 cents, huh? 1 minus answer. And then remember what this we're going to do. Let me write the answer down here.
There we go. Interest rate was too high.
674.42.
Yeah.
Is it all good? So remember what we do with this denominator? We bring it up and we go times 12 over 0.059, right? Times 12 divided by 0.059 equals. Then that's the whole right side. Final thing you do is you take 83,678 divided by answer equals. All right. You guys getting that okay? 674. All right, I'm going to leave it behind if you guys are good. You all getting that number? Oh, this is how they calculate those. All right, so let's try that. Monthly house payments necessary to amortize a 4.8% loan put to death, a 4.8% loan of $135,200 over 20 years. Suppose you buy, so notice you're buying a house, $135,200, right? How would you know which formula to use? Well, if you buy the house or buy the car, you have the car now, or you have the house now. Present value, right? The bank gave you the money now, right? The pile has come to you now, right? Present value. So that's present value of an annuity. So there's the formula. Is that good? So there's the present value. So give it a go. See if you can plug stuff in. I can't even read it now. I wrote over the top of it. Is that 135,200? Is that what that is? Yeah, 135,200. All right, plug this stuff in there. And you're trying to find the monthly payment. You're trying to find the R, huh? So you're trying to find the R. So it's just like the last one. This is how those online mortgage calculators work. This is what they do. You could write your own online mortgage calculator. Something I know you've always dreamed about doing. Give this a try. One more time, what was that?
877.39.
877.39. Anybody else getting that answer? Yeah, good. Looks good. 877.39. Right, want me to plug in here? I'll show some of the details. You plug in, so the P, the present value, the pile now, the house value now, 135,200. Trying to find R, the payments. 1 minus 1 plus the little r is the interest rate, 0.048 over N. What is N? Monthly, right? N is 12. Minus 12 times T. T is 20 years over R, which is 0.048 over 12. So there we go. So figure out the right side on your calculator. So on the calculator, it's 1 plus 0.08 divided by, 0.048, huh? 0.048 divided by 12 equals to the power. So whenever I finish parentheses, I have to hit equals, right? To the power. Now, this is minus 240, that power, huh? To the power of negative 240 equals 1 minus answer equals, and then you flip up this denominator, times 12 over 0.048 times 12 divided by 0.048 equals, and then take the 135, 200 divided by answer equals. And we get the answer. 877.39. So that's what your house payments would have to be. 877.39. You got to pay that every month, and that'll kill the debt, the loan of $135,200 over 20 years. That's what it'll do. Plus, you've got to pay taxes and insurance. That's just principal and interest. All right. Is that good? Questions on that? We good? Of credit cards. Ain't nothing like the numbers, to tell the truth. All right. So, new employee charged $98.70 on his credit card to relocate for his first job. After noticing that the interest rate was 18% compounded monthly, that's pretty typical for credit cards. It's like armed robbery. He stopped charging on that account. He wishes to pay off his balance in 2 years using automatic payments. So knows what does his payment need to be, basically. So this is a big pile now. See how, if you read this on the exam too here in a couple weeks, how would you know? Well, the big pile is now. We're not saving up to make a big pile later. We've already taken a pile of money now, right? The $9,870, the credit card company gave us the pile of money to go spend now. We have to pay back the pile, right? So it's the pile now. It's present value of an annuity. So it's present value, R, same formula we've been using, which I still don't have memorized, 1 plus R over N to the minus NT over R over N. Okay. So, and they're saying, all right, here we go. We're going to plug in the stuff. What monthly payment? We're trying to find the R, so it's 9. So the present value is a $98.70. The payments we're trying to find. 1 minus 1 plus. The interest rate is a whopping 18%. N is 12, isn't it? Yeah, monthly. N is 12. To the minus 12. What's time? 2 years, right? Wants to pay it off in 2 years. Okay, there it is. We've got to solve for R. So you know how to do it, right? On your calculator. So go ahead and calculate. See if you can get that. So on the calculator, we'll take 1 plus 0.18 over 12 equals to the power minus 24 equals 1 minus answer equals divided by, oh no, times. Flip this up. Get this guy and go times 12 over 0.18 times 12 divided by 0.18 equals, and then take 98.70 divided by answer equals. Everybody getting it? 492.75. 492.75. Anybody getting that? Couple of you, good. 492. Make sure you can get that. And then we're going to talk about, they have another question for us, but let's make sure we're all first getting to there. 492.75. So we good to there. And then we're going to do something with this. If I can go to another sheet here. I didn't really give you notice I was going to do that here. Everybody got that down? We got that down okay? So I can shift to another screen, but do the 492.75. What I'm going to do now, what they're going to basically ask me now, well, the first question is, what's the payment? So that's 492.75. Then part B is going to say, how much total interest will he have paid? Now, how can we figure that out? He's gonna. What is his 492.75? This is what he's gonna pay every month out of his account to pay back the debt in 2 years, right? So he's gonna pay this back every month for 2 years to pay back the debt. So can we figure out the total amount of money he's gonna pay? We just gotta take this times 24, right? He's gonna make 24 payments, right? 2 years every month. That's what he's going to pay for 2 years every month. So let's just go to the new screen and say, okay, I already forgot. What was it, 492.75?
Yeah.
75. He's going to pay, that's the payment for 2 years. Monthly for 2 years. So let's just take the 492.75 and go times 24 payments, right? 24 easy payments, like they always say, right? I don't think 492.75 is an easy payment. Anyway, it's not easy for me. 492.75 times 24 payments, he's going to pay $11,826 paid back. That makes sense? 24 payments. Now, what was the original debt he took? Yeah. So subtract the $9,870 because that's what he borrowed. Right, subtract the 9870, and you get $1,900. What is that? $1,956. That's the interest, right? Because that wasn't what he owed him. He borrowed the 9,870. That was the original. He borrowed. Why did he have to pay more back? Because they're charging 18% interest a month. So he paid almost $2,000 in interest on under a $10,000 loan, just under $10,000 loan. To realize that's about 20% interest. Well, it's 18%, right? Compounded over 2 years. He paid about 20% for that. That's a lot of money. Interest is the price you pay for the privilege of using somebody else's money for a while, right? That's what that is. $1,956. So that's a lot. Don't try not to use credit cards. I would encourage you. They're in business for a reason, right? And you know what you really don't want to use is the payday loan places. You know those places? Those places are crazy. Yeah, what do they charge? 40%? Oh, right after we do the yeah, it's crazy. You know those you see them all over town. Payday loan or places like that. They're illegal in like 17 states out of the United States, not in California, but in many other states they are illegal because the way they're charging you is crazy rates. And you might think, well, no, they're just like 15, 20. I mean, it's high, but it's not good. Well, yeah, but it's for every paycheck. It's not for a year. So in other words, if you think what their rates are, like this is 18% per year. Credit cards are high, but they're not illegally high. I mean, they're not like seemingly just like buying food at the movies, right? Just crazy, right? That's payday loan places do that for one paycheck, for like 1 month, right? So it's way more. It's crazy. You don't want to go. Those they're bad. They're bad. I mean, they really. I had a buddy about 20 years ago, and when he got started on one of those places, him and his wife came up a little short, and then so he went to the payday loan place. Right, he had a week or two before his next paycheck came. He was a little low to pay the bills, and so you give them your check, and they give you your next check's money a couple of weeks ahead of time, or a week ahead of time, or whatever. But they take whatever 18% or whatever it is, right? But then guess what happens the next month? You just had whatever 10% taken out of your paycheck, and you took it early. So the next month you're short again, even shorter, and so you come to them again, and you come to them again, and it's like drugs almost, right? I mean, you're hooked, right? That's what happened to my buddy, right? He was just every month, and so basically, effectively, they're taking 18% of his money, just because he's short every month, right? Just because patience and waiting and that kind of stuff. Anyway, all right, I know you'll see the news one day, and you'll see me locked up because I blew up a payday loan store while nobody was there at night. They go, "That was my old crazy math teacher, Mr. Heron. I knew he hated those places." I always drive by with the kids. I always go, "Evil place, kids." See right there. My kids know the whole spiel. They've heard it 27 times backwards and forwards about the evils of. Okay. So determine whether the given ordered pair is a solution of the system of equations. So how do you find out if, like, 8-2 is a solution to those two equations? What do you do? Plug them in. Just plug them in, right? So -9. So the 8 is the x and the 2 is the y. Remember, it's always x first, then y, right? So you can just plug in the 8 where you've got the x and the 2 where you've got the y and see if it makes the first one true, and then also see if it makes the second one true. What is that? Just use your calculator. -72 plus 2, which is -70 equals -70. It's yes for that one. My 7s look a little funny there. Okay, how about the second equation? 7x plus y is 58. Put in the 8. Put in the y, the 2 for y. What do you get? 56 plus 2 is 58. 58 equals 58. Yes, it made them both true, so the answer is yes. That means that point, those two numbers, which together make an xy point, make both equations true. There is a solution. That 8-2 is a solution to both equations. Thus, it's a solution to the whole system of both equations. If either one of those had been a no, we would say no. So to solve the system, you got to solve them both. So so in the elimination method here, I want to make these two front numbers be the same, one positive, one negative. So really opposite. I want to make those two front numbers opposite. So how can I make those two front numbers opposite? What can I multiply by? Whoops, that didn't help. What can I multiply by? Do you see that I can take that top equation and multiply through by 2? Because 2 times 4 will be 8x. And then it'll be the opposite of the minus 8x below it. Do you see what I'm doing? So remember this from algebra? So the name of the game, I probably scribbled over it too far there. The name of the game is to make, it's going to go boom, boom, boom. And that top equation will become 8x plus 4y is minus. So now the bottom equation, just bring it down, no change. Minus 8x plus y is 57. See how I made the front x's opposites? Right? I multiplied that top equation by 2. Why 2? Because that made an 8x. That's the opposite of minus 8x. They're the opposites of each other now. Right? One's a positive, one's a negative. We good there? So now I can add those up and the x's will drop out. Everybody seeing that? The x's will drop out. 4y and 1y is 5y. 57 minus 12 is 45. Am I going too quick? See what I'm doing? I'm just adding, subtracting vertically, straight up and down. Now, why am I doing all that? Yeah, so and now I've only got one letter. You see, I got x to drop out because I can't really handle both letters at the same time. I want to get down to just one letter. And now I've got it. I've got only one letter. How do I finish solving for y? Divide by that 5. Y is 9. So I got my hands on y. But now I need x also. So how do you get x? Do you remember this from algebra?
Plug in 1.
Just plug it in. Yeah, bring it up here. Plug in y equals 9. Where do you plug it in? Anywhere you want. Anywhere you want. You can do the first equation, the second. I'll just grab the first one. It matters not. Just grab that 9 and plug it in for y. This coming back to you? Like a sweet memory from the past? Maybe not that way. Michael, you loved it. You had me for, you get razzed when you were in my former algebra student.
Still having dreams.
Okay, good answer. All right, subtract 18 from both sides. 4x is minus 24, right? Yeah. Divide by 4, x is minus 6. So the answer then is minus 6 comma 9, because you've got to give x, y. That's the final answer. The answer, they want the two, see how they say, you can't hardly read anymore, it says ordered pair. Type in ordered pair. What that means is they want two numbers with a comma. Negative 6 comma 9. X comma y. That's the x and the y values that would make both equations true at the same time. All right, you guys like that? Now, everybody got that copy down? Now we're going to do it on our graphing calculator. And I don't care which way you do it. Are you ready? So I'm going to shift off of that screen if you guys have got that copy down. Take your graphing calculators out. First thing we have to do is enter the entire matrix into our calculator. What do I mean the entire matrix? I mean this thing. See how it's 4, 2, minus 6, negative 8, 1, 57. Where am I getting at? There's a 1 here. See how I'm just peeling those numbers right off of the x, the y, and the numbers on the right side of the equal sign? See what I did? I just went to the original question, and I just said 4, 2, negative 6. 4, 2, negative 6. Negative 8, 1, because there was no number by that y. 57. Negative 8, 1, 57. Matrix, right? You got to enter that on your graphing calculator. And I'll send you YouTube, but I'll say some things now. Ooh, the time is a-running, huh? But I'll say some things now about how it actually works. So let's do that. So let me come back over here. Okay, so again, 4, 2, minus 6, negative 8, 1, 57. We're going to put that in as a matrix. Now, how do you put things in a matrix? Well, Kevin, you're kind of on your own with that Casio. I can help you later or YouTube it. But for the TI people, so let's go to your TI-84, and we're going to hit something, which I don't remember. There's a matrix button. Oh, there it is. So there's a matrix button down the left column. Everybody see that? Let me turn this on here. Oh, it's got to turn that off, huh? All right, so there's a matrix button down the left column. Hit second for the TI-84. Hit, or TI, TIs. Hit second matrix, which is above the, what is it? The X inverse key. On the left, there. Okay. Okay, so see it right here? See matrix right there? So hit second, we're going to have it on first here. Second matrix, and you go into the matrix menu thing. We good there? So hit second matrix. Now, first, here's how it's going to work. You basically have to first enter the matrix. So we're going to type in those 6 numbers, in a certain way. I'll show you how. And then we're going to exit. Let me give you the big plan first. We're going to type in the 6 numbers, and then it's going to store it. It's kind of like using a word processor or a spreadsheet. You're going to type in the data, then come back out of it, and then go back in and tell it to calculate on that data. It's in 2 phases. So first phase is just inputting it. So that's the editor. See how there's up across, there's names, math, and edit. Names, math, and edit, right? You go over to edit because you want to edit. You want to enter the data now. Hit enter. So notice I'm on A or 1, edit. So I'm going to edit or enter matrix number 1. Hit enter, and there it is. Now, mine says 3 by 4. I don't know what's on your screen, but what I want is a 2 by 4. That matrix that was on the screen is 2 down. It's always down first. 2 down, 3 across. 2 down. So it's the opposite of graphing. Normally graphing, you go sideways first, right? Then up, down. It's the opposite for matrices. Down first, then across. 2 down, so enter 2, enter, 3, enter, and it'll set up a 2 by 3 array. Now just put the numbers in. 4, 2, hit enter every time. 4, enter, 2, enter, negative 6. Make sure you use the negative, not the subtract. It'll freak out for some unknown reason. There. So I have entered the 6 numbers. 4, 2, negative 6, negative 8, 1, 57. Is that good? When you hit enter on the last one, it's got it. It's stored. You can turn off the calculator. It's got it stored. You don't need to mess with it. In fact, it's got it stored as matrix A in its memory banks, because that was what was next to the 1 when we first went into this menu. It's stored as matrix A, or 1. Does everybody see how that worked? So I'm going to quit. I just hit second, quit. You can just turn off the calculator, everyone, turn back on, whatever. I hit second, quit, back to the normal screen. Now I'm going to go back into the matrix world, hit second, matrix. I know matrix A has got the information stored. Oh, you know what? I'm sorry, I messed up. Hit second, quit. We don't want to do that yet. We want to hit RREF. And I don't know where that is. Second matrix. Oh, yeah, I do. Go over to math. Oh, yeah, it's okay. I'm changing my mind again. So go back into second matrix. Go over to the middle menu. There's names, math, and adding. Go to the middle, the math one. These are the math operations that you can do on the matrices. Go down to RREF. There it is. There's a ref and a ref. You want the RREF. Reduced row echelon form. Not going to be tested on that. So that's what it stands for. Hit enter, and it puts back on the main screen RREF of something. It's ready for you to give it something. It said, I'll do your RREF for you. Give me a matrix, and I'll do it. Everybody good? Everybody with me to that point? Now, we go back, and we hit second matrix again. We keep going in and out of the matrix menu. Go back to the matrix menu. See how I'm under names now? I'm going to name it matrix. Just hit enter. You're right there. You're on matrix 1, which is matrix A. Enter. And it puts an A back in those parentheses. See how that worked? And you don't even need to close the parentheses. Just hit enter now. Boom. There's our 2 answers. Negative 6, comma 9. See them in the right edge? It just did the work for us. Negative 6 and 9. That's X and Y. Those are our answers. We get that? So let me go back to the screen. Let me write out for us. Make sure. So we hit second matrix. Went in there. We choose a 2 by 3 because it's 2 down, 3 across, and enter the matrix 4, 2, negative 6, negative 8, 1, 57, and then hit second, exit, and then go back into second matrix, and then what do we do? We go over to the math. Oh, this was over to the edit menu also, wasn't it? Oops, I'm kind of changing my mind. Over to the edit menu. This was over once to the math menu. And go down to the RREF, hit enter, and then, what was it? Then it was second matrix, and enter, and enter. I think those were the button presses that work. We'll have to do more of this next time, so I won't make this due yet. Just the other section will be due, not the 6-1. But it won't take much longer, maybe 10 more minutes, because once you have the buttons down, it's just the same buttons every time. So if you want to hang out, I can show you how to do that 6-1 more, or we'll do more of it next time in class.